We just looked at arcs. So now let's look at the second part, sectors and their areas. A bit of terminology. A minor sector is one that has an angle of less than 180 degrees, and the major one has more than 180 degrees. I hope to show how the angle of the circle is related to the sector area, in the same way that the angle is also related to the arc length of the circle. In fact, we can see that the area ratio for a sector is exactly the same as for an arc. In the same way, the angle over the total angle is the sector area over the area of the circle. And rearranging, we get this formula. Let's hammer this intuition a bit more. We see a circle with a sector area split at 180 degrees. So we would expect that at 180 degrees, which is half of 360, the area also would be half. You can play this out by swapping in the values. And here we get that the area of the sector is half of the circle's area, which is what we expect. Let's move on to the exercises for the sector area. Take a moment to pause and understand the question. So now we need to find the area of the minor sector OAXB, which is this region. To do that, let's remember the ratio relationship between the sector area and the angle. Rearranging, we can get a formula for the sector area. And notice that theta in this case is the angle of OAXB, which is 120 degrees. And the radius is 10 centimeters. So let's sub in those values and we can simplify. To this. Now let's move on to the second part of this question, which is to find the area of the major sector OAYB, which is this region. And if you remember, we could do the exact same thing as we did in the first part of the question in this second part, which is to find the ratio of the area of this major sector OAYB and relate it to the angle of this sector. But we could do an easier way, which is just to take the total area of the circle, pi r squared, and subtract the minor sector area away from that. So we just do this. And since we already have our minor sector area, which is 100 over 3 pi from the previous part, we can get the answer easily. Before we continue on, here's a summary of the formulas that we've used so far. First is the arc length related to the circumference and the angle, as well as the area of a sector related to the area of the circle and its angle. It's important that you realize that these come from ratios first and foremost, and then we derive the respective formulas for the arc length and for the sector area. Pause here and think a moment about how we got here.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.